getting set up here.
Okay.
So assuming you can still hear me, Howard?
Yes, I hear you.
Okay. So hello, everyone. You've obviously been hearing the last few minutes here of our conversation. Apologies if you got bounced off of WebEx. But we do want to thank you for joining us today for our October Team Studio PLCC webinar. Our speakers for today are Howard Greenberg from PLCC and Ulrich Kraus, who will hopefully be joining us here in the next few minutes. And they'll be presenting on how to improve the performance of your XPages. So my name is Colleen Bedrikian, and in addition to Howard from PLCC, who's presenting today, I'm joined by Paul Delanedia of PLCC. And just to review on the agenda today, we'll take a few minutes to tell you about Team Studio, who we are and what we do. And then Paul will take over and give you a little bit of insight about PLCC. And then we'll have Howard and hopefully you'll dive right in. Before we get started, a few administrative things to cover. We have over 300 attendees today, and to protect your privacy, the attendee list is not public, so you'll only see yourself on that list. You're all muted during the session, so participation will be through the chat window and the Q&A panel. Q&A panel will be, as it always has been, at the end of the session, but you're welcome to ask your questions in the Q&A panel at any time throughout the presentation. We'll just get to it at the end. This session is being recorded. If you have registered for the event, which you all have at this point, we'll be sending an email out with a link to the presentation recording as well as the slides. If you like what you're hearing today, feel free to share it with others. Our Twitter handles are listed here on this slide. With that, we'll just get into a little bit about who Team Studio is. We may have assisted you in the past with application development. We've been developing innovative developer tools and productivity tools for the Notes and Domino community since 1996. And some of our tools include source code control, version management, source code management. And in 2010, we moved into the mobile space with our Unplugged platform, which mobilizes Notes and Domino-based applications. So Unplugged gives you the ability to extend your Notes application to other mobile devices. The unique thing is that Unplugged leverages powerful technology of XPages, which you're all here to learn more about today. And what Unplugged does is it provides a native application experience for the user through XPages. These applications have the capability of functioning offline because that's the unique value add of Unplugged. And then lastly here, Unplugged was selected and awarded the IBM Collaboration Solution Award at Connect earlier this year. The platform is available for major mobile platforms, BlackBerry, Android, and iOS. And then since the launch of Unplugged, we've also launched some templates and applications that you can use as developers, Team Studio Continuity being one of them. This app, the Continuity app, allows users to import their business continuity plans, crisis emergency plans, and call trees so that the information is available to them if the connectivity ever becomes compromised, which it frequently does during disasters. So, and Team Studio Continuity also works on a major platform, so BlackBerry, Android, and iOS. A couple of things that are coming up. Our next webinar will be on November 19th. This session will be about deciding which applications you should web enable or mobilize. We'll send out more information about this webinar in the next weeks when we have a registration link where you guys can register and learn more about who the presenter is and what the details are of the presentation. We'll be presenting with Wytria on October 24th at a DC Lug event. If you're out in that area, please come by and join us. More information is available on the Team Studio homepage. And then on October 19th, we'll be presenting at a VLUG event, All Things Mobile. So if you're out in that area, please join us there. And then lastly, one of the promotions that we're hosting this month, if you'd like a chance to win a free iPad mini, contact us for a demo of our continuity application. You can click on the banner on our homepage for more information or reach out to me directly. So with that, I'd like to pass the presentation on to Paul so he can talk a little bit about PLCC. So give me 1 second, Paul, and I'll just pass controls over here.
Okay, thank you, Colleen.
All right, should be coming over right now. Okay.
And,
Like you have it.
oh, I lost my interface to share my screen. And I'm looking for that. Someone remind me how to share my screen here. Seems a little different.
Share.
Say again, Celine?
Sorry, if you go to Event Center, WebEx Event Center, and go to the top, it says share, and you can share my desktop.
Yeah, and that's what I'm missing, my Event Center at the top. I've got the interface on the right.
You can Control Tab until you find Event Center.
Ah, here we go. Okay, is everyone seeing my screen? Okay, apologies for that. Thank you, Talene. Good morning, good afternoon, good evening, everyone. My name is Paul Delaneve. I'll be your host for today's webinar. And today's webinar is the Autobahn has no speed limit. Your XPages shouldn't either. A little bit of housekeeping. As Celine mentioned, next webinar, November 19th. To view any of our previous webinars, you can go to tlcc.com and view one of those. We've got quite a collection there. A little bit about TLCC. We've been around since 1997 providing training and consulting services. We offer courses for Notes and Domino administration and Domino development. We offer the broadest curriculum in the industry to learn XPages development, and we deliver our training in both self-paced courses and instructor-led courses. This chart shows some of our new Release 9 courses. All of those titles and many more are also available for Release 8.5. If you haven't tried one of our courses, I do encourage you to check out our free Introduction to XPages development course. That's also available in 8.5 and 9. And we have extended our fall sale to October 31st. So great time to buy one of our courses or one of our low-cost course packages. This chart summarizes the XPages skills path, and you can kind of place yourself and your existing skills somewhere along this path. Certainly, your core Notes Domino skills apply. So your understanding of Notes database, Notes view, Notes document architecture, Domino security, all of which form the foundation of the data and security layer of your XPage applications. Also, most of the add functions and simple actions have been ported, providing that familiar basis for coding your server-side events. If you have skills in working with the Domino object model, Notes session, Notes database, Notes view classes, all of that is exposed to your server-side events. You certainly need JavaScript skills. So JavaScript is the primary language for coding your XPage events, both your client-side and your server-side events. From there, you would develop your core XPages skills, and we have an XPages Development 1 course that's slotted to deliver that skill set. And from there, you might continue your journey by expanding or even specializing in areas like user interface or mobile XPages development, very exciting area, or even Java development, where you can develop your business logic and application interfaces through Java classes and leads. Certainly TLCC can help. We have self-paced courses right along that path. But as I said, we do deliver on-site training as well, and we've been delivering quite a bit of on-site training this year. So if you're part of a development team, contact Howard or myself, and we can certainly talk to you about providing some custom training and some custom courses right on site. As Celine mentioned, Q&A will be at the end, but as we go along, certainly post your questions in the question and answer area, and then I'll provide a voice at the end of our session. Okay. Howard, do you want to join us while I do the introductions here?
Sure, I'm here. I am here.
Do update me. Has Ulrich joined us?
I don't believe so. We have not heard from him.
Okay. Well, that puts you in an interesting spot, doesn't it, Howard? So
we'll do the best.
Hi,
we can.
hello.
Oh, we have a Ulrich.
Yeah. Here am I.
Your timing is impeccable, Ulrich.
Okay. Okay. I sense a bit of relief in Howard's giggle. Anyway.
I was ready.
Okay, let me introduce your presenters today. Okay, for our main event, we have two IBM champions contending to unify the North American and European belts. In one corner, he's a founding partner here at PLCC. He successfully defended his IBM champion belt for 2 successive years, hailing from Boca Raton, Florida, Howard Greenberg.
Yay. Now, Paul, I'm not going to attempt to go against Ulrich when it comes to Java experience.
Well,
I'll concede this battle.
Well, no, you can't just give up right away. Go around or two. In our other corner, he's a senior architect at BCC. He's successfully defended his IBM champion belt for 3 successive years, hailing from Dusseldorf, Germany, Ulrich Krauser.
Yay, wow, great.
Is that pretty good?
That was pretty good, yes, excellent.
Okay, kidding aside, let me pass over the control to Ulrich. He's going to start out our presentation today. And Ulrich, I think you have control of sharing your screen now.
Okay, are we already live or is it just a test?
Oh, no, we are quite live.
Oh, we are live. Oh, that's great. So, welcome everybody. I hope you can see my slide now. This is the agenda.
We're still waiting to see your slide.
Ah, you're still waiting. Just a second. Where is the control?
From the menu, you can. Oh, there you go. I think we're seeing your slide. We're seeing your desktop now and your slides. Thank you, Ulrich.
Okay, sorry for the delay. So now you can see the agenda for today. So the first part is what factors affect performance, and the next one is the JSF Lifecycle listener. You have to learn about, you have to know it to understand what is going on your XPage, to find the bottlenecks in your XPages code and to improve performance. When it comes to updates or execution of special parts of an XPage, the partial update or partial refresh and the partial execute mode comes into play. We will show you some tools, how to measure your performance so you can act on it. And at the very end of the show, we will show you a step-by-step optimization of a very slow database or a very slow application to a very fast application. And there are some coding factors that come into play. So first of all, the view navigator versus the get item value. We will show the advantages of the view navigator and also the advantages of using Java instead of server-side JavaScript and how to use the string builder, which may give you a performance boost. And for all of you, the opportunity to ask questions at the end or during the show. And okay, so let's start. Let's first have a look at a typical XPages request. It doesn't matter if it is a post or a GET request. Most requests start with a click on a button in the browser. So some client JavaScript is invoked, and it is sent from the browser over the network to your server, which is typically a web or application server. And then the JSF context and the XPages stuff kicks in, the JSF Lifecycle begins to live, and it goes from the restore view phase over all the phases until we have the render response, which is sent back over the network to the browser. And at the very end, some Dojo code may be involved. And you can imagine that at all of these points, something can go wrong, or there may be some bottlenecks. that will slow down your application, and we will try to give you understanding where to keep an eye on and what you can actually improve to make a better user experience and to speed up your application. So first of all, we have hardware. Regardless if it is a client or a server, we have a hardware which mainly consists of three components: the CPU, the main memory, and the hard disk. So for the main memory, this is where we have scalability. So the more memory we have, the more requests we can we can serve, and this is only limited by the operating system and also the CPU. There are cores, the clock speed, and cache, first or the second level cache, and if you have a weak CPU, you have a poor response time. And put it all together, a weak CPU and a low memory, this is poor overall performance and a poor response time, and maybe your server may hang. And also the hard disk comes into play. So speaking of I/O, if you have a lot of I/Os and a very weak hard disk, so this is also impacting performance. And yeah, maybe you will look like this man on the right side. A little bit of crying, your computer may smoke and does not perform as you expected. So we've seen the responses are sent over the network, and also on the network we have two factors, which is the latency and the bandwidth. By the way, this is a picture from my daughter's room. I'm not responsible for the network. This is our own setup, but I've seen it in bigger companies. It looks a little bit like this in most of the companies, a lot of cables wide, and nobody has control actually if it is a good connection or not. So latency, this is the time taken for data transmission between multiple computers on a network, and the bandwidth is the rate of transmission of data. And it is clear that a greater bandwidth and lower latency, you will get a better connection. So keep an eye on it, and you can measure the bandwidth, you can measure the latency, and you should do it. What you cannot measure, you cannot control, and just do it, measure it, and well, tweak it so you get a better connection then. So we have seen client sends it to the browser. As I said, the hardware is one factor, but also how many data requests and responses are transmitted from the client to the browser. How much data actually is transferred. This is the size of the data. If it is a kilobyte bit, or if it is several kilobits or megabit or whatever you have, and also watch on the caching of resources, which can be controlled in the application or can be controlled in the browser itself. And also one factor is the client-side JavaScript. If you have lots of client-side JavaScript, it may slow down your application. And also, what's the size and the complexity of your CSS? So the bigger the CSS, the more data has to be loaded from the server to the browser, and the browser has to work on all this CSS. So keep it clean, keep it short and simple, and this will speed up your application to some extent. And also, do not make your sites too complex. So the complexity of the site structure is also a performance impact. When the browser sends it to the HTTP server, we've seen it goes over the network. So network latency is again a factor. The bandwidth, we said lower latency, greater bandwidth, better connection, and also there are some limits on the concurrent download. So the Internet Explorer 7 allows 2 downloads at a time, and the Internet Explorer 8 allows 6 downloads at a time. And also there are some limitations on other browsers like the Firefox or whatever you have on your system. So internally, the HTTP server communicates with the application server, and here we have the Java virtual machine heap size and the garbage collector, which is a performance factor. Also the CPU time, the competition between threads, gives a slower response time, and threads can be controlled by default. It is set to 40, but there are some IBM recommendations which can be read from the statistics where you have to tweak your threads to another number, but you have to measure it. I forgot to put the link to the IBM site into the presentation, but we will do it in the show notes or whatever we can put some information on these slides. We'll give you some more information on the slides later. So the app server and now the actual Domino context kicks in. The number of read design elements from the NSF is a factor regarding performance. So class files, form structure, and whatever you have it, and also back-end API calls may be expensive, especially if you are dealing with a large data set, and we will see it in a couple of minutes. And also the design elements, they have to transfer from the server to the browser. Maybe a lot of network requests, and yeah, this should be limited to have a good user experience, to have a fast application. Lifecycle, we spoke of this, and I think Howard will give you some more details on the lifecycle later in the show. There are file system reads, so this is where the hard disk comes into play. You have to have a fast hard drive, hard disk to handle all these file IOs, and also concurrent access can block some parts of your application. So this is also to take into consideration when speaking of a fast application, what you have to do. And last but not least, re-evaluation of some part of your page, of your code, should be reduced to the minimum. Some parts are re-rendered every time in most phases on every control. And at the very end, we have the browser. When it all comes back to the browser, there might be some inline JavaScript, which you should avoid it. Simply avoid it to use inline JavaScript, and also try to reduce Dojo requests for JS files of Dojo modules that are not loaded at this time. So here's some general performance options you can set in the Node.ini file. There are two variables to be set. It's the HTTP JVM heap, max heap size set equals to 1, and also the actual heap size, which should be set to 1/4 of the available RAM. You have to put both variables into your Node.ini, otherwise it won't work. If you do not need HTTP server logging for your web page, simply disable it. And also, as I said, watch the thread count. It is set by default to 40, but you can tweak it to every number you want. You have every number you need to have a good response from the server, to have a good experience of a fast application. And in the development environment, we surely have Java debugging enabled, or with Nodes 9, we also have the JavaScript debugging enabled. And this should be disabled in a productive environment. So this will have an impact on performance, and also if you debug, no other user can actually access the application. So keep this in mind. The persistence mode, this defines how your JSF pages are handled, if they are serialized to the into memory or on the disk. So there are three settings you can have. So all pages are persisted on disk. So the memory is not so much overloaded with XPages files. But keep in mind, this may be a lot of I/O on the hard drive. There are also another setting, which is the file X. So all pages are persistent on disk except the current one, which stays in memory. I think this is the most common setting that should be used. Or all pages stay in memory. This can be used for small XPages application with a quite low number of users. So for every user, the XPage stays in memory. You have to have a lot of memory to handle all these requests. So I would recommend to use a file X setting to keep only the current one in memory. This can be set here in the in this setting. JavaScript and CSS aggregation is a new function which came with 8.5.3, I guess. Prove me wrong. I think it was 8.5.3. And this groups many Dojo CSS JavaScript files into one single file. So this means that we have less requests from the browser to the server and performance improvements, especially on networks with high latency. And also it enhanced the performance parsing of the CSS and the JavaScript. Last but not least, we have fewer connections to the server, and so the server can handle more requests at a time. You can set it on an application-based. You can set it application-based. It's in the XSP properties. It may be a little bit different on 8.5.3, I guess. This is a picture from the Domino 9. But the settings are all the same. So you will find the use runtime optimized JavaScript and CSS resources, which you have to check, application-based, or if you want to do it server-wide, you can put an extra line, an additional line into the XSP properties file on the server. The XSP resources aggregate equals true, and you have this setting enabled for all your applications. Here is how it looks like if you do it with the Firebug extension for Firefox. So the picture below shows the result of the loading of a page if this feature is disabled. So you can see there are a lot of requests sent to the server, and the response comes back. A lot of small files are loaded, and especially we have the time. It is almost 1 second to load all this stuff, and here we see the feature enabled. So you see there are less files loaded. They are aggregated into 1 or 2 smaller files, and also this reduces from 886 milliseconds down to 157 seconds. A good performance improvement. In 8.5.3, there is a new feature which is valid for the server and the client. It works on both. It's the XPage Preload. You can set it. There are also 2 parameters in the nodes I and I to set. The first one is the XPages Preload equals 1. And in general, the XPages Preload loads Java classes from the XSP runtime plugin. There are a lot of these runtime plugins, 435 in Nodes and Domino 8.5.3. And also a lot of classes that are referenced in the basic config files are also preloaded. How does the server know what to preload? This is the second parameter, the XPage preload database equals, and then you can have a single XPage in an application on the server, or you can preload a complete application on the server or on the client. If you watch on the console, you will see it's an output similar like this. So the XSP command manager initialized, and then the preloading stuff kicks in. And the preloading works on the application level. This is basically the same as a user would open an application on the server or on the client. So the application is loaded on the client and server at startup into memory. This happens when the application is first opened in the browser. And for each entry in these node I and I variables, an XPages URL is generated and sent to the server. Then the XPages is loaded and the HTML is generated, but it cannot be displayed because it's in the background. So the XPages runtime discards the HTML, but retains the application in memory. As a developer, you should be familiar with the so-called scoped variables. We have variables. We have scope variables for flavors. The first is the application scope, and this is a variable that is visible for all users and for one application. And it expires sometimes after the last user used an application scope variable, so it does not live or persist forever. The second one is the session scope variable, which is valid through the session of the current user, and it expires sometimes after some time of inactivity for the current user, and one user does not have access to session scope variables and content of session scope variables of another user. Next one in row is the view scope. This is visible for the current page only, so as long as you stay on one page, this variable and the content is accessible, and this is useful for transporting a search query, for example, to a view or something else. And the last one is the request scope. This is valid only for one request of the current user, so just a click or in a drop down, you select a value and put this into a request, and as soon you access this value, it is expired and discarded. As I said before, the application scope does not live forever, but there are some situations where you do not want to wait until the last user exits the application to update the application scope. Think of putting some company names, some country code, and so into an application scope to make it to have a quick access to these values, and you want to update this. And here's some piece of code I have lent from a good friend of mine, Mr. Matt White. And normally, as you can see in the above picture, you would have a function like init application, where you just check if this application scope init application variable equals null. If it does, then you load a profile and fill some values into an application scope variable, and then access this variable. If you want to update it, there is some clever cache mechanism which Matt White provided, and you can use it to update, for example, the application scope of the application init every 10 minutes or so. So play with it. It comes very handy if you have to update application scope variables and do not want to wait until the last user exits the application. So next up is Howard Greenberg, as we already said, an IBM champion, the founding partner of PLCC. And yes, I think I have to stop the sharing to hand it over to Howard. So Howard.
Thank you, George. You have to drag the little ball next to your name over to my name.
I have to? What?
Oh, hold on.
Oh,
yeah,
okay.
I think you did.
Okay. Sorry. Here we are. Make presenter. Okay.
Got it. Thank you. Okay, so from Frankfurt, Germany, now back to Boca Raton, Florida. And let's see. Do you see my screen, George?
Yes, it's green now, and here's the slide. Yeah, here we are.
All right, very good. Okay, so part of that life of XPage that George was showing involved the JSF Lifecycle. So what is that, and why do we care? XPages are built on what's called Java server faces. That's what IBM chose as the underlying underpinnings of XPages. And they did make some changes. Not everything, applies. But what happens is when the XPage is submitted to the server after the user had made some changes or edits or something like that, the request goes to the server, and then there's 6 phases that happen. And so these 6 phases have to happen before a response is sent back to the web browser. So let's go through these phases just to get an understanding, and then we'll look at the actual impact on an XPage. So the first phase is called the restore view. And so all the controls on your XPage are also called components, and those are all part of what's called the component tree. And that component tree resides in memory. And so if that component tree is not in memory at the time the request comes in, it has to be loaded into memory. And that's what happens in the restore view phase. The next phase is we have to take the data that the user entered into the edit box or the combo box, all the various controls that are editable, and we have to apply that data into the controls in our component tree. And so that phase is called the apply request values. And so that is where the data actually gets bound to the in-memory representation of our controls. The next phase is called process validation, and like the name sounds, this is where we do all the validation. So all those validators that you created, wherever you checked off on a control, this is required, or created your own validator or used one of the other ones, those validators run. If it passes validation, it goes through a conversion phase. So some of your controls, let's say an edit box, are going to be bound to a number, let's say, in your Domino document. So that has to be converted to a number before it can be actually saved as part of the Domino document data source. So that's called the converters. So if either the validators or the converters find a problem, we stop the processing and we go right to the last phase, which is the render response phase. But assuming the validators and the converters worked, then we go on to the next phase. And this is where the data in the controls are moved to the actual data source. So for example, your control on an edit box, the data in that is actually going to be copied to the Domino data source. The next phase is called the invoke application, and this is where your application logic will happen. An example of that would be an on-click event of a button or an on-change event of a combo box. So this is where that logic will happen. And the final phase might be the most important. This is where all those controls in the component tree get converted back to HTML and sent back to the browser. So that's called the render response phase. So while we're talking about these phases, we also, I'm sure everyone who's done the XPages work is aware that on the XPage and also in the panels and things like that, we have events. So on the XPage, we have an after restore view event. Well, that's going to run after the restore view phase. Then we also have a before render response and after render response phase. So that's going to run before the render response phase starts and after the render response phase starts. And then we also have an on-client load event on the XPage, and that's going to run in the invoke application. So these different phases can obviously, there's a lot of processing going on. So to kind of illustrate this, I borrowed some code from Tony McGuckin from IBM. He has an excellent video series. It's a couple hours long. And also there's some demonstration databases. And these are up on OpenNTF. We have a link to those on the last slide that you can, if you want to dive more into this, you can, view those videos and get the demo database and try it out. But what this demo database has in it that's interesting to us is something called a phase listener. And the phase listener is it's all it does is print out to the console when the phase starts and print out to the console when the phase ends. So I've incorporated that phase listener into this database that you are seeing now. And I've created a simple XPage. And on this XPage, let's look at the first label control here. Notice I have the visible property, and that's called rendered as well. And in this, I have return true, but I also have a print statement. So we're printing the rendered property for this ID and getting the current ID. In this case, I am computing the label, and I also have a print statement. So these print statements are all going to appear on the console, and then the phase listener is going to show us in which phase these print statements occur. So I have an edit box. In the edit box, I have a rendered property as well. I also have a validation on this. And in the validation, I use the validate expression where I can write some code. I'm actually just saying return true. It's always going to be validated, but I'm doing a print statement again. So we're going to see where all these fit in. I have a combo box, and in the combo box, I again have a rendered property, a visible property, and I also compute the values in this combo box. Of course, I have a print statement there. So we've got lots of print statements that are going to happen to the console. Then I also have two computed fields. They're basically the same. I've got a visible property, and then I also compute the value. It's just going to display the current time and date, and also have a print statement. And finally, I have my submit button, which has a on-click event, which I have a print statement, of course. And in this case, we're doing a full update. So I'm going to run this XPage, and you see it's pretty straightforward, and really nothing happens when I submit it other than the time changes. But the real reason we did this was going back to the presentation is that we want to see when did all these print statements appear. So when I first loaded this XPage, the only thing that happens is the render response phase. None of the other phases get calculated. And you see that in the render response phase, we went through all the different rendered properties for all our different controls. We computed the label, computed the default value for that one edit box, some more rendered properties. We computed the values for the combo box. For some reason, it does it twice. We computed our computed field 1 and 2, the value and the rendered. So that's pretty straightforward. So let's look now at what happens when we do a post request or when I click that submit button. So here's our life cycle, and I put the various printouts, print statements for those different rendered properties and value properties in the appropriate phase that they occurred. So this is kind of interesting. Notice that the rendered property happens not only in the apply request values phase, and in fact, for some of these controls, it happens twice, but it happens, all those rendered properties happen again in the process validations. Of course, it also does our validation for that one edit box control. And then it also redid the values property for the combo box. Again, in the update model values, it did all our rendered properties again. And then in an invoke application, it did the on-click for the button. And then in the render response, it went through and did everything again. So that adds up to a lot of server-side JavaScript. 39 times we had to call out and run server-side JavaScript for this particular XPage. So that's a lot of processing. And this happens on all our XPages, and they're actually still pretty quick. So it's actually kind of amazing that this all happens so fast. But still, we want to optimize it. We want to keep in mind ways to optimize it. So let's look at some options. Okay, so everyone is familiar, hopefully, with the server-side JavaScript editor. And what you may not have paid attention to is at the top of the server-side JavaScript editor, we have an option to compute dynamically or compute on page load. The default is compute dynamically. Most of us probably never change that. I know I never did when I first started coding this. That happens, by the way, when we choose compute dynamically, in our source view, it puts a pound sign in front of the JavaScript code. And the pound sign means it indicates that it's going to compute dynamically. If we chose compute on page load, it would put a $sign. And that means that it's only going to compute once on page load and will never get recomputed again. So no matter what you do in your button, unless that button has code to reload the page completely, it's not going to recompute that particular server-side JavaScript. So this is great for values that are not going to change. If you only need to compute it when the page is first displayed, this is what you want to use. You want to use the compute on page load. And let's look at why. So I have that same XPage, but I've taken all my rendered properties and I changed it to compute on page load. So I did this for all the rendered, and I also did it for the combo box for the values, compute on page load. So if we look at this in our source view, where I have the rendered property, you see right here, I have the $sign. Opposed to where I had the default value, I didn't change that. That has the $, meaning it's going to compute dynamically. So let's go look at that and see what happened when we went through our phase listeners and looked at our console. So I changed, again, all the rendered properties to compute on page load only, and as well as the values property for the combo box. Everything crossed out did not happen. That's what happened before. So we only did the validation in the process validations. We only did the default value property. We did the on-click event of the button. And in the render response, we only did the label and the computed field 1 and 2 value properties. So we saved 33 server-side JavaScript calls. So that's a pretty significant savings. But of course, you're going to say, I need the dynamic rendering. That's one of the nice things about XPages is we can say, you know, the user can click a button, maybe they entered some information, and then you want the XPage to look different to move the user to maybe the next part of what they have to do in that particular application. So what can we do to speed that up? So we can't use that on-page load option for server-side JavaScript. So one of the things we can do is be a little smarter about what we put in that rendered property. We have scope variables that Ulrich mentioned, and those still would, you know, if we say that in our rendered property we want to look at a particular view scope variable, it's going to load that in from memory. That's going to be a lot faster than if in your rendered property you did an @db lookup. So what you would do is figure out and set in your scope variables whatever values you need to then use those scope variables in your rendered property and have that be nice and simple. And not do your heavy computation right in the rendered property. The other option we have is something called data context. And these are a way to compute a value at the XPage level or a panel level or a custom control level. And then we can refer to them with what's called EL or expression language. Expression language is kind of a way to avoid using server-side JavaScript and instead refer right to the value of a particular variable. In this case, the variable is a data context. So you can think of the data context as like a global variable, similar to the scope variables, but something that can be applied to just part of an XPage, because you can scope these, again, at the XPage level, custom control level, or a panel. So let's look at that. And I have a XPage, again, the same XPage. But what I did was, at the XPage level, I went to my all properties, I went to data context, and I have one already created. But to create a new data context, you just hit the plus symbol, and it will give you a new data context. But I have one already created here. And what I did was in the value, I put in my server-side JavaScript. Again, I have a print statement and return true, and I'm computing it on page load. And then I can refer to this in my rendered property by just using what's called expression language. So in my rendered property, I have right here, it just says show controls. Notice it doesn't say JavaScript in front of that curly bracket, or I should say right after the curly bracket. It just says the name of the variable I had in my data context. which was, just to review, go back to my XPage all properties, my data context. The variable was called show controls. So that variable I can use, and I want to use it ideally as a expression language. So when I created this and went to my rendered property, I used the expression language and just said show controls, the name of the variable. And so when I run that, we'll take a look at that in a second. Now notice that I had the data context, in this case I had it on page load. If I set it to run dynamically, the trouble is the data context get recomputed multiple times. And so that may not be good, and so you want to be careful with that. The ideal way to use the data context are to use them on page load. And if you have to change them as your XPage, goes through its various, changes, if for some reason you want to change the data context, I have a link here. Paul Withers has some code up on XSnippets on OpenNTF, and he talks about it in his blog entry on how to set a data context from your code. So then I can go in and actually change the value of data context from code versus setting it to be dynamic when it's going to have this performance issue that it has. So that link is in the slides. You can get that when we send the slides out. Let's see, did I miss? Okay, I didn't have that. So that would be another way to speed up the execution of our XPage. Okay, so here's another way, and if you're just starting out in XPages, or even if you've been doing this for a while and you don't know the difference between partial refresh, which is also called partial update, and partial execution, or you've never heard of these, I know when you sit in these webinars, you tend to bounce between your email and listening, and okay, sometimes we fall asleep. So wake up for a second. This is important. Just give me 5 minutes here, because you need to know the difference between partial refresh, partial execution, and what these do. And these can really help your XPages, not only in performance, but also in the user experience that they're going to have. So what I'm talking about here is in your events panel, you have the ability to turn on partial update. And a lot of us call that partial refresh because that's what it's called in the source code of the XPage. So I'll use those terms interchangeably. Partial refresh will still compute the entire XPage, but in the render response phase, it will only do the part of the XPage that we specify in the design or user interface. So in this little picture, I'm saying only refresh panel 1, and that will only be the only part of the XPage that gets sent back to the browser. So let's look at that for a second. Let's close that. Okay, so partial refresh. So I have a panel here. It's in yellow. I have a yellow background. And I call that panel panel 1. In my submit button, I have in my events, I said only partially update or partially refresh panel 1. And if we look at the source code, you see why we call it partial refresh too, because it's called, the property is called refresh mode. When we say refresh mode equals partial, refresh ID specifies the part of the XPage that we're going to refresh. Okay, so when I run this XPage, you see that our times are the same here, right? And I can put in a value here. And I click the submit button, and notice that the time only changed in the yellow panel. The other time did not change. So let's go look at what happened in our life cycle. Okay, so now that I've done that partial refresh, remember only what was in the yellow panel, panel 1, that we computed. So everything else still got calculated. We still did all that work in the apply request values. We did all that work in the validations. It even validated the part of the XPage that wasn't refreshed. Again, in the update model values, the on-click event of the button ran. And then only in the render response did we have a savings, because it only did what was in our panel 1, that yellow panel. So that's the only savings. We saved 9 server-side JavaScript calls. The other savings that you don't see here is that it only sent back to the browser what was in this yellow area. So that could be savings as well, because of your network latency that Ulrich mentioned. Okay, so going back to the partial execution. I didn't talk about that yet, but that's only going to calculate what's in the area we specified. So we'll actually show you how that works in a second. Let me go through the pros and cons of partial refresh or partial update first. Again, you saw that in the render response phase, we did have some savings there as well, but it still went through the entire, all those other phases. We also had a better user experience. You couldn't really tell from my little test XPage, but obviously if you're just changing part of the XPage in the browser and you're not changing the whole thing, the user is going to see that one little part that needs to change. Everything else will stay the same. It won't flicker as it changes. That will be a much nicer user experience. Now the downside is if we have anything like a computed fields only get calculated in the render response phase. And because that computed field 1 wasn't in our panel 1, that time never got recalculated. So you got to be aware of that. And also, now that I told you about this, don't go to your production apps and turn this on until you thoroughly test it, because obviously there might be some logic you weren't aware of that can affect it. The other con is you can only update one area. So in that refresh ID, I can only specify one ID, and there's a workaround that Tim Triponi has on his blog. Yeah, we have a link there that you can get. So the partial execution. Let me actually show you that in Designer first. Partial execution is only going to execute what we specify. So in my button, I'm going to say, I'm going to change it back to a full update. I'm going to say only partially execute panel 1. Now, for my code in this button to work, I have to make sure it's in the area that's going to get partially executed. So I move my button inside my panel that's getting partially executed. Now this is Designer 9. If you have 8.5, your interface is a little different. You don't have the button to select the element. So what you have to do is go to the source view, and you just have to put in, you can select the partial execution in the design pane here. You still have that checkbox. But then you got to go to the source code and put in the exec ID and specify the ID of what to partially execute. So remember to do this, because if you don't do this, then the only thing that's going to get partially executed is this one button, whatever code is in the button. That's what will get executed. Nothing else in the panel will get executed, or nothing else on the XPage. So always specify the exact ID. And let's see what happens now that I partially executed what's in this panel. Notice that in my, going back to the life cycle, that we only did what was in the panel 1. That was the computed field 2. We did the rendered phase in our 3 phases still. But in the render response, we did everything. And when I go, let me go back to the browser and run this. Let me start from my XPage. Okay, so let me put in some values here, combo box, and I'll click the button. Okay, so notice that the values in the for the computed field both change. Remember, the computed field 1 happens in the render response phase, so that always happens. But notice that my values outside the panel 1 got set back to the default values. Okay, so when I submitted this, my default value got reset. So we actually lost whatever edits the user put in, because it only did those phases. Remember that apply, going back to our chart, the apply request values is where the values get bound to the controls. That didn't happen for our edit box. That only happened for our computed field 2 that was in that panel 1. So you got to be careful with using partial execution in that if you have any values the user entered, they have to be inside the panel you're partially executing for them to be saved. So we did have some significant savings here by getting rid of those. So it is a tool you can use. Okay, so going through the partial execution pros and cons, we definitely reduced processing in our 3 data processing phases. And however, in the cons, the button had to be inside that panel 1. Our editable values that did not get submitted or updated, that were if they were outside of the executable area. And again, if you have existing XPages, you know, think, test before you turn this feature on. Okay, now let's look at combining both of those. So what I did here is we went and we combined the partial execution and partial refresh to partially update that yellow panel, panel 1, and partial execute that panel 1. And so what we did now was only did what was in that panel 1 for both the calculation point of view and the render response. And so now we saved 33 server-side JavaScript calls. So this is great if, you know, the user changes something, maybe it's in a dialog or only in a tab or something, and you know the user only changed what was in that part of the XPage. You send that up to the XPage, recalculate, you know, what was in that part of the XPage, and you saved a lot of processing. Okay, so now let's talk about another option. This is not so much a performance to some extent, but also you can use this. What you can do is turn off the validators. And this is great when you want to send some data back up to the server, but you don't want it validated because you're only in an intermediate phase of your XPage. You just maybe want the XPage to change its appearance because the user entered some information, but we're not ready to submit it yet, so we don't need to run our validations. This also would update your values in your backend Domino document data source. The other thing we can do is this checkbox here, do not validate or update data. That's in the source. It says immediate equals true in your, let's say, button or whatever you have. This won't run the JSF Lifecycle phases, process validations, update model values, and invoke application. So nothing in your Domino document data source will get updated. So this might also be of some help depending on what you're doing. The other thing to be aware of, a lot of people make this mistake. They use the loaded property, and then they try to access, the loaded property means it will, if loaded is equal to false, that control will never get loaded into memory. And if it's not in memory, that means you can't access it. So we can't go back in later in our code and access that control to then change the loaded property equals to true to display it. To do that, you need to use the rendered property. So if you have controls you know you're not going to need to use for that particular invocation of the XPage, the loaded property is great because it's not going to be in memory, not going to be in the component tree, not going to go through any of those phases. So that's another option as well. Okay, just to kind of summarize my little part, and I'll turn it over to Ulrich. I realize we're running over a little. We did start late, so bear with us. The lifecycle performance, a lot of the properties, you know, most of what I was talking about were the rendered property, where it was computed multiple times. But a lot of the other properties like the style, CSS style that you have, or many of the other properties only happen in the render response phase and don't have that penalty issue, the performance penalty that the rendered property has. You know, try to use scope variables in your rendered properties. Try not to do a lot of heavy computation in the rendered properties. And whenever you can, try to use the partial refresh, partial execution. All right, before I turn over to Ulrich, one thing that I've discovered in trying to figure out how good or how quick are the add functions, I look at the @db lookup. And I set up 5 lookups, and then I loop those 5 lookups 100 times. So we're doing 500 lookups. One way I did the @db lookup, the other way I used the get document by key. The results were really amazing. The @db lookup was 3 to 4 times slower. Okay, so I'm not saying all the app functions are bad, and some of them I think for string handling and things like that are really pretty useful. But if you're doing @db lookup and doing a lot of them, be careful, and especially, again, knowing what you know now, especially in a rendered kind of situation, because those are going to get computed multiple times for one control. Okay, now back to Frankfurt, Germany, and Ulrich.
Okay.
Control over to you, Ulrich. Let me find the appropriate tab here in my WebEx. Okay. I want to change presenters. Hopefully yep, I got you.
Okay, so can you hear me?
I can hear you, and we're starting to see your screen.
Wonderful. So, okay, here I'm back again with my part of the presentation. So, a web page wouldn't be a web page if we do not have any images on it. So, if you have images on your web page, use a correct file type depending on the context, on the content. So, if you want to display detailed images or detailed images, use a JPEG, and if you have only simple information to share, like a button, use a PNG or GIF for this kind of stuff. And for faster HTML layout in the browser, size the images before you use them. It does not make any sense to have a 3 megabyte image loaded and then use the height and width attributes to size the image to the size you need on your page. Also, think about using CSS sprites instead of single images. So if you have multiple small images, put them together into one bigger image. This is a CSS, this is a sprite image, and the underlying CSS or the corresponding CSS only displays the relevant subset of an image at a location in the page. There's no support on the XPages itself, but the One UI theme uses a lot of these sprite images. So here's how it basically works. We have a sprite image, which consists of 3 single images. There are some tools on the internet where you can just upload your small images and you get the sprite image back along with the HTML to access the single parts of the sprite. And this is the CSS for this little guy here, and in your XPage you just simply add a style class with the value of home to display the home image, and when you load your XPage in the browser, it will just present a subset of this sprite image. So this is only one image is loaded and it is kept in cache and only accessed by switching the CSS in your HTML code. As I said before, you have to measure the performance of your XPage to make some considerations how to improve the speed and how to improve the user experience. And there's one tool which you can get for free on OpenNTF side. This is the XPages toolbox, and it's also an XPages-based application. It runs on the Domino server and on the client, and you only need one NSF on the server to be installed, and also a profile or jar file should be edited to the launch options of the Java virtual machine. Then you have to restart the server, of course, to make this effect. And then you have the XPages toolbox to measure the performance of your XPage or speed of your XPage. You can measure the CPU performance and also the memory allocation of your XPage application. In 8.5.2, there is extended support for backend class profiling, and we will see this backend class profiling in a second when it comes to the step-by-step optimization of a very slow XPages application. This is how the XPage toolbox looks like in the browser or in the client. And you see you have a CPU timer profiler, you have a wall timer. This is actually, sometimes the CPU timer does not show where the bottleneck of your XPages application is, but the wall timer does. Read the documentation for this tool, and it will become clear what is the difference between these options. You also have the backend profiler, I will show you in a second, and the runtime monitoring and the memory inspector, where you can generate heap dumps of the Java virtual machine in the HTTP class. You can do it by clicking a button in the XPages profiler, or simple from the Domino console by invoking these two commands on the command line. To analyze the output of the heap dump, you can download an Eclipse tool, the memory analyzer tool, and you also need to download a plugin from the IBM side to read the files that are generated when you do the heap dump. Here's how this looks like, and this is a very good tool. If you have your heap dump, you can you can have a good overview what are the top consumers in the Java virtual machine. Maybe some objects are loaded multiple times and stay in memory, and this consumes a lot of memory and drags down the performance of your XPage. More tools, of course, we have seen this before, a simple print statement in the render, visible computation, and so on, in the XPages root control, before and after page load events, and also in custom control root events. This is a very simple method of doing some output, of doing some measurement, and see what actually happens during the execution of the XPages code, and also to see what happened in the JSF Lifecycle listener. You need some output to see, okay, this is computed here in this phase. Also, you should use a task manager and or a process explorer to show CPU usage and process memory usage as it happens. And all we know, these browser tools in Firefox, in other browsers, also the Internet Explorer now has some developer tools. And as I said before, we have the Java and JavaScript debugging, and if you have turned it on the production machine, this will degrade performance, but you can still inspect objects, but switch it off on a productive environment. So now for the step-by-step optimization of our application. This is a simple model. We have our performance sample application, and there is some XPages code involved, and this displays a pretty this is actually a custom control which I downloaded from OpenNTF. This is the jQuery plugin in form of a custom control. You can copy it to your application, and you can pass the values in form of XML or JSON or read text file. There are multiple options to get your data to this grid. And I downloaded it and gave it a try. I have 18,044 documents in this application. And when I first started the application, it was pretty slow. So what happens? What happened? I took a look at the actual original source code from the sample, and here is how it looks like. This is straightforward server-side JavaScript. It reads all the context from the application into a document collection, then loops through the collection and assembles a JSON by reading the values from items in the document. You can see it here. This is a while loop, and we just assemble the JSON, reading the doc via get item value string from the first name. The last name should be here, state and city. And then I ran this code, and I also have the XPages toolbox active. And here's the output. We see reading and displaying 18,044 document takes 87 seconds. This is very slow, and 18,000 documents are not so many documents. You might have more documents in your application, and you can imagine that this will be not a good accepted application by the user. So the backend profiler shows the bottleneck. We have here, getting the universal ID is a get operation and it takes a very, very long time for only 18,044 calls compared to the get item value operation or method, which is called, and it takes less time than just to get the universal ID. So the first idea was, if this takes a lot of time to get the universal ID, why not have the universal ID in an additional item on the document? So I changed the code, and you can see the changes here in yellow. So I put in an extra field and had it computed when the document is created. So I refreshed all my documents, so I had the universal ID in this additional item. And this is the only change to the code. And when we now do another measurement, we see it is down to 81 seconds, which is a little bit of an improvement, but it's not very fast. But you can see that this time also increases here. And the explanation is simply that it is not only to get the universal ID from the document, but to open the document first. And this is what consumes more time than just to get the value out of the document. So not a good idea, so I reverted it back. And the next one was to say, okay, when we assemble this long JSON code in our code itself, why not have it on a item in the document and do all the calculation for the JSON in this document when the document is saved? So this is the formula I used in my item. It used a transform, which is not very widely spread used, and also a get field. And you can simply throw in your item names here, and it will assemble the JSON for you. You do not have to take care about all this escaping of characters and so on. And also it reduces the size of the code because we only have one get item value string here, only reading the field JSON. Let's see how this improved the speed. So down to 28 seconds. Wow. And you can see it here, it's only getting one item value 18,044 times, and it takes 2.1 seconds. Good, but not good enough. Because having this extra field, this is redundant data in a document, and we always try to avoid having redundant data in documents. It's not a good idea. So I said, okay, what I can do in this document, I can also do in a view. So I just moved the formula from the document item to a view column and changed my code to read the view. So we get the view here, context single column. This is the formula. This is the output. And I also did some other improvements. I set some options that are recommended by some other guys to speed up reading of the view and so on. This is what the code looks like. And let's see how this works. Okay, we had 28 seconds before. Now we have 26 seconds. This is not much a big difference. Okay. So I tried to find out what the reason is. Why is it so slow to read it? Why is it so slow to assemble all this JSON? And as an aside, this is the actual reason why. So you have to understand what happens when you assemble a long string or lots of strings with the plus sign, which is the easiest way you can use in Java or in JavaScript to glue together a lot of strings to a bigger string. Each time you append something via the plus sign or even via string concat, which is a method you can use with a string, a new string is created, the old stuff is copied to the string, the new stuff is appended, the old string is thrown away, and so on. The bigger the string gets, the longer it takes. So I did a measurement only with one character in this string. For example, it took 10 seconds to glue together 100,000 of these one single character strings. If you double it, it will take 20 seconds. And now you can imagine what it takes to have a very long string assembled together. So the recommendation is you can use the plus sign, you can use the string concat, but only do it if you have only 2 or 3 operands. And if you have more than this, or you are dealing looping over a lot of data, which we actually do in our application. Avoid to use the string, the string concat or plus. Use a string builder instead. Here is a little test I did this weekend, and this is some sample code. We are going from the slow one, which just uses the plus sign. You see this is our pound sign, and we glue together 1 million times. A little faster, another method which should be proved to be faster is the concat, and the fastest is the string builder, and you can see the results of the slow. This takes a very long time to build this string, and the faster, it's quite half the time that takes for the slowest alternative we have here, and the fastest one, which is the string builder, only takes 32 milliseconds. So this being said, and this kept in mind, I changed my code and now use a string builder instead of the plus sign to assemble the JSON code. The other code didn't change much. Let's see the result, and it's down to 2.375 seconds here. This is pretty much a good improvement, but not good enough. The next step is, if you look at the JavaScript code, the server-side JavaScript code, and we are right now started using Java with a string builder in our code. So the idea was, why not use Java instead of server-side JavaScript? So I built a Java class in my application, and I have a getViewColumnValues JSON method in my class where I can pass a view name and the position, which is the column in the view I want to read, and all the reading is done in this code, and the method just returns this big JSON string we need to pass to our grid to display all the data. And here's the according server-side JavaScript code I have in my XPage. So I just call with a new de-ignore view column. This is my class, and I'm calling the method, passing the parameters, and give it to the writer, and then output it to the XPage. And here is how it looks like. So this is a real good improvement. Recall, we had 87 seconds at the beginning, 82 seconds at the beginning, and now we have it down to 1 second, 1 single second for all the data to read and to display with a few very simple steps you can all do in your application to speed up your application. This is the result, 1 second, and here's also some homework to do. I'm not sure if I should pass it back, so I do it here. There is an article on the JSF Lifecycle. It's a non-XPages explanation how this all works. Also, Paul Withers blogged a lot about XPages, part 1, 2, 3, which are all different links below. And I had the honor to participate in Dublin at the XPages masterclass, which Tony McGuckin was one of the hosts, and he explained in 2 days, along with Martin Donnelly, how all this stuff, all the JSF lifecycle works with the improvement and so on. It was 2 days packed with technical stuff, and he tried to compress all this content into 4 very, very good videos you can download following this link also on OpenNTF. And yes, I think
actually
it's time for the questions.
Yes.
Back to Howard.
Ulrich, if you continue to share your screen and simply advance to the next slide.
Yeah. This one.
And we can take, yeah, just leave it there. And we'll take your questions right now. So there are a couple of questions that have been queued up, but again, if you have any questions, post them in the question and answer area. And we have a question from Kim. How much of a factor, a performance factor, does design compression have and come into play with XPages? And Ulrich, I think this came up during your discussion.
I can address it too.
Well, go ahead.
Okay. I think, Kim, design compression is something that helps out the Notes client. And actually, IBM, it works by default in the mail template. But I don't think it does anything for XPages, even when they run in the Notes client, because those are basically converted to Java, and it's a web application, even when it runs in the Notes client. So I think the answer is probably not at all. George, do you have any feelings on that, or are you aware of that?
I also think it's good if you have to deal with space on the server, but I do not think that it is much of a performance improvement, especially what you said in XPages. So there are other, like the single copy template or so, which gives you more improvement on XPage, but I don't think the design compression does a job here.
Yeah, that's a good point, George. We didn't mention the single copy XPages template, but that does have some performance benefits when you have one design that's shared among multiple applications, because then that design, one design will stay in memory, and all the other applications can share that design. So that's a good performance improvement as well.
Okay, I have a question from Leon. Ulrich, you mentioned latency and bandwidth and the effect on performance. Are there tools to measure latency and bandwidth?
Yeah, you can have switch it on the client itself to measure. It's a debug option you can set. I'm sorry, I can't recall it by now, but we can put it in the show notes, which gives you a overview how long it takes to submit a request from the client to the server and back, and so you can measure latency. I think also Wireshark does a good job there. So you can put it into your network and just watch what happens on your network and get some measurements from there. Yeah.
Yeah, Firebug does a good. I think it's in
the
network.
Firebug as well. Yeah.
In the network tab has a great shows you all the files that load and everything.
Okay. General question from Wyman. First of all, comment. Presentation was great. Are the slides going to be available? Yes, you will be receiving a follow-up email with a link to the recorded webinar and to the slides as well. Another question from David. What's the best, from a performance point of view, persistence setting?
I think it depends on the complexity of your application and how many users access the application. So if you have a lot of users for the complex application, I would recommend only to keep the current page in memory, so the file X setting I mentioned before. If you have a not so much seen application with a low complexity, you can set it to keep all pages in memory. So memory access is always faster than doing the stuff on the hard drive. So it depends, really depends on the complexity of the application, how many users are accessing this application.
Okay. Another question from Greg. Are there any best practices for using the data cache property of a view?
Maybe yes, but I don't know.
I'm not that familiar with it either.
Okay, let's throw in another one here. Question from Charles. Any considerations for using multiple servers and IP spray to scale an application? Is that another one of those?
Well, I think one issue with that is, I don't believe the Domino server supports, it's going to have to go to one particular Domino server because of all the session variables and everything else, and you can't, have a XPage served to a user and then have it submitted to another Domino server. That won't work. So not quite sure how that would happen if you're using multiple servers with an IP sprayer, because there is no support that I'm aware of that by IBM to do that in Domino. So unless you'd have to have some way to guarantee that the user always went to that same IP once they were assigned to it, at least for the life of the XPage.
Okay, we are a little over time, so just a couple more here. This one I think I'll just answer. A question from Wyman. Does XPages support pass-through HTML? Certainly, right in your XPages source editor, you can enter in your inline HTML. Another question from David. When I guess, Howard, this is more addressed to you. When you're printing to the console with those print statements, is that the server console? Yes, that is a server console, but here's a variation on the question. For a local XPink application, where's that going? Is it going to the status bar?
No, it won't go to the status bar. It'll go to the log file.
Okay, so that's your local log file.
Right, and also I'll point out there is an OpenNTF project called the Log Reader, which is a great way to view your different logs and consoles on the server versus going to the server and either opening up files or just viewing the console directly. It's called Log Reader, and it's on OpenNTF.
Yeah, and you can also start your clients with a special parameters, the end params equals whatever have you. I have to look into it, and this will open the OSGI console, and it's pretty much the same like the server console. So all print statements you have in your XPages code will print it on this console locally on the client.
Okay, and I think we should wrap it up at this point in time. I'd like to thank everyone for attending today's webinar, and again, look for details for our next webinar in November. Talene, would you like to add anything at the end here?
Thanks for joining us in November.
Okay, thank you everyone, and have a great day.
Thank you.
Bye-bye.
Bye.